Hi students, this is the video for 2.2, the first half of the notes, where we'll talk about inductive reasoning and going through some of that. So 2.2 inductive reasoning, we did do some of this in class the other day, so this might be review for you, but inductive and deductive reasoning is what 2.2 is on, and this video is going to focus on just that first part of inductive reasoning. So exploration number 1 we did in class, and we looked at the patterns that were happening here. So we wrote a conjecture about the pattern, basically just describing what you see. So for A there, you're describing that you see that the tan ball is going from the bottom right to the bottom left corner to the top corner, and then back to the bottom right corner, and so on and so forth. And that's the conjecture that you're making based off the pattern that's happening. Okay, we also did exploration number 2 and looking at Venn diagrams and how to read them, talking about if things were true or false based on those properties in that Venn diagram. And then exploration number 3 we skipped. If you would like to do exploration number 3, you can pause the video and then I will have the answer up there for you. So here is your Venn diagram for the relationship between the different types of quadrilaterals, squares, rectangles, parallelograms, trapezoids, rhombuses, and kites. All right, so inductive reasoning. Here's our definition for inductive reasoning. So we have a conjecture is an unproven statement that is based on observations. You use inductive reasoning when you find a pattern in specific cases and then write a conjecture for the general case. Like the patterns we were looking at, we were making conjectures and making an observation, so we were using our inductive reasoning. When we get to deductive reasoning, the second part of the notes, that's going to be more based on facts. So inductive is more based on observation and patterns and stuff like that. So example number 1 here, we have figure 1, figure 2, figure 3, figure 4. It says describe how to sketch the 5th pattern, then sketch the 5th pattern. So this is our figure number 5. You should have noticed that it was putting another block on each end of our figure. So we have the other one of on your own here. That video is on connected to your online textbook if you would like to look at that on your own. Example number 2 says make and test a conjecture about the product of a negative integer and a positive integer. For this one, we know, so we're making an observation of what we see when a product, when we're multiplying a negative integer times a positive integer. So if we have a negative number times a positive number, we know that this is going to equal a negative number. We have observed this time and time again ever since we've been doing multiplication, that a negative number times a positive number will give you a negative number. So that would be inductive reasoning and our conjecture. Next we have counterexample. Our definition for counterexample is to show that a conjecture is true. You must show that it is true for all cases. You can show that a conjecture is false, however, by finding just one counterexample. A counterexample is a specific case for which the conjecture is false. So example number 3 says a student makes a conjecture about absolute values. So they noticed a pattern, or they noticed something that potentially worked. We want to find a counterexample to disprove the student's conjecture. So they said that the absolute value of the sum of 2 numbers is equal to the sum of those 2 numbers. They might have noticed this by doing specific absolute value, but we could look at an example. If we took the absolute value of negative 3 plus 2, this student's conjecture is saying that it would equal the sum of negative 3 plus 2. So if we look at this, the absolute value of this would give us +1, whereas if you just add these two together without the absolute value, you get -1. These two things do not equal each other, so therefore we just gave a counterexample for that conjecture to disprove it. So if you would like to do the on your own, you can. Again, the video for the on your owns are attached in your textbook for those examples there. Core concepts and deductive reasoning will be the next video. Thanks.